Okay, students, here I am. If you see this lesson is lesson number 8, is about cubes and cube root. So if you see the learning goal here is I can solve equations by cubing and finding cube roots. So let me go directly to the practice problem, cumulative practice problem. So remember, uh, two things we have to remember, that if x square is b, then x equals plus minus square root of b. And if it is x cube is b, then it is straight away x is cube root of b. If it is x raised to 4 equals b, then it is x equals plus minus fourth root of b, something like this. So whenever it is odd number, if the exponent is the odd number, then it is x is fifth root of b. So now in the first case, the question is select all equations for which minus 3. So they ask. So let's begin with the first one. If I plug if the first case, so the first one is x squared. We can straight away apply this. So this becomes x is plus and minus square root of 9. And this is square root of 9 is 3. So you have two answers. One is x equals plus 3 and the other one is minus 3. So there you go. So there's a solution x equals minus 3. So they're asking which of this equation has got the solution, and we have seen the first one is correct. So I'll say, hey, this is one of the answers. But in this case, second case, you're getting x equals plus minus square root of minus 9. Now, in the radical sign, whenever there's a square root, you cannot have a negative. This is not possible. So here, not possible. And later on, we will see we are going to use complex numbers to write this in the form plus or minus square root of 9 times square root of minus 1. And this one we are going to define as imaginary unit, which is I, and that becomes plus or minus 3i. So right now, in this lesson, you don't have to worry. You just say, hey, b is not the correct. You cannot have uh, square is always positive. Square cannot be negative. Watch this. Any number, any number, let's say if it is minus 3 square, it is going to be plus 9. If it is plus 5 square, is 25. So always positive. So there is a x square cannot be negative. And the same thing e also, you will see here, this means minus x square is 9, and if you divide by minus 1, you end up getting x square is minus 9. So you cannot have square is negative. So this cannot be the answer. This cannot be the answer. What about C? So C, we can use what number multiplied itself 3 times? You can see here. So what is that number which multiplied 3 times to get 27? And the only answer you can think of 3, 3, 3. Because 3 cube is 27. So 3 times 3 is 9, and 9 times 3 is 27. But you can't put minus. I can't put minus 3, minus 3. So you cannot have two answers. Because if it is this, then it will be minus 27. Yes. Yes. So the question was asked whether this one, the only solution is x equals 3. But we wanted to know which one has minus 3. So this cannot be the answer. Then D is the answer. Let's see. Okay, here it is. X cube is minus 27. Now here there's minus 20. Just now I was saying, right? You can get minus 27 if you put minus 3, and minus 3. Or it is like x is cube root of negative 27. So basically asking what number multiply itself three times to get negative 27, and the answer is minus 3. So minus 3 is the only number. When you multiply 1, 2, and 3, you get minus 27. So cube root of negative 27 is negative 3. Of course, you can also write this as negative 27 raised to in the fraction form or rational form, 1/3, this also is correct because nth root of b is same as b raised to 1 over n. So I hope I made myself clear. So this gives you the answer as -3. This gave you x equals -3. And what about the f part? This is same as minus x. Minus x equals 9. So two negatives makes it positive. X times x is x squared equals 9. So x becomes equal plus minus square root of 9. So two answers, +3 and -3. So you get another answer. There you go. See? So I hope I made sense. So your correct choices are A, and then you have D, and then also you have F. Question number 2 is saying use the graph of cube root of x to estimate solutions to the equations. The first one is cube root of x is 2. So the graph is given. This is the graph of, so this is graph of cube root of x. So now all we do is when will be the output y. So this is like output or the y value. It's 2. If you see this is the y value and I can go just cross here and you go all the way down and this is like approximately, it doesn't have to be correct. So if this is like 30, this is almost like 10. So I will write the first one is what is x is, maybe x is 10 here, or maybe some of you will say no, it is 8. I'll still 9 or maybe 8. No matter what you feel, you just decide that. The second one is negative 4.5. I'm going to use a red one. So negative 4.5 is this one. So I go all the way this way and it touches somewhere here maybe. And that goes all the way to -90. So this is -90. And the last one is 375. And this I will use different green color maybe. 3.75 will be somewhere here. This is 3. And this will be 3.75. It goes here. And then you go down. And I don't know how much is this. Maybe it is like 30, 40, 50 here. So that answer is 50. But the question is, they asked me another question, B part. We want to know exact solution. What is exact answer? So I'm going to take this off. So there's a B part which we have to do. And that is going to be the actual and not just estimating by just looking at the graph. And the formula is like this. So if this is the case, you cube both sides. That means, remember, if x cube is b and x is cube root of b. So this is going backwards. That means x here is 2, the b, this b. So this is like x is 2 here. So this has to be cube. So 2. So the x that you see, the x here is the red x, right? This is like the b here, right? And the 2, so you may get confused. Let me clean this off and something change it to different variable. It means suppose I have a cube is b, and a is cube root of b. So right now in the radical sign the x is b. This is that x. Okay, and the a is the 2. I'll use the green color. This a is 2. Okay, so all you do is going backwards. So that means the b becomes equal this red. So this b will become equal. So the x is, all you do is cube. So you cube this. So so the green, watch this color that I'm showing. This two, the green one, you have to cube. So this is the green one, see? So therefore your answer becomes equals x equals 2 times 2 times 2, 2, you're done. And the same thing, the next one is, again we use the formula, so x becomes equal negative 4.5 and you cube it. And now you can use calculator or you can do the actual, because if there is a minus, remember minus, suppose you have minus 1 and if you cube, it is minus 1 and minus 1, still you get minus 1. So this minus sign stays as good as writing 4.5, and using the calculator, you see the answer is going to be minus 9 point, sorry, 91.125. And the last one is, so this one will be x equals 3.75. So using the calculator, you will see this answer is going to be 52.7343. This is the exact answer. I hope I made sense to you. So just to remember, this is important. And also another thing is, if you cube root of minus, let's see, if I put minus b is same as writing cube root of c, but minus out with the minus sign outside. So here, which are the solution for this one? Again, same idea. See, now you directly apply the formula. It means what multiplied itself to get minus 125. One thing we know, it is 5, right? 5 times 5 times 5 is 120. But there is a minus, so you can put minus, minus, minus. So that means minus 5 raised to 3 is the answer. So the only answer we have is x equals minus 5. But how do you write this is, you write x equals cube root of n. This is how you're supposed to write. Short. So that's like a formula straight away, but this is explanation how it works. So what you expected is to know this part and you're done. Problem number 4 is complete the table, but remember you have to use powers of 16. That means when you want to write here, this has to be 16 raised to something, 16 raised to something, 16 raised to something. And what do you get? How do you get from here to here? So the only way possible is you have to put a minus 1, because 16 raised to minus 1 is 1 over 16. It's because a raised to minus p is 1 over a raised to plus p. The second one is, we'll have to work this out. 16 raised to minus 3/4, we can write it as 1 over 16 raised to 3/4. And this can be written as 16 1/4, and then I can write it this way, applying the formulas. And this means this is actually fourth root of 16. So, and what number multiplied itself 4 times to get 16? And you know the answer is 2. So 2 raised to 3, so you get 1 over 8. So this answer becomes 1 over 8 here. Now how do we, what goes right here to make it 1/4 there? Now you know, this 4 which is down is a square root of 16 is 4, right? Which is 16 raised to 1 over 2. So we can, but because if it is 16 raised to half, it would be 4. But because there is a fraction, I'll have to put minus half there. So this will be, so this has to be minus half. Because, let's see, let me show the steps how that works. So 16 raised to minus half, suppose I write 16 raised to minus half, is same as 1 over 16 raised to half. And that is same as square root of 16. And square root of 16 is 4, and that fourth is right here. The next one is, we'll have to work this one, we have to work it out. So again, I'll drop it down, 1 over 16 raised to 1/4, which is 1 over 4th root of 16, and which is same as 1 over 2, because 2 times 2 times 2 times 2 is 16. So this fourth root means what number multiplied itself 4 times to give 16, and the answer is that 2 here. So this answer becomes 1 over 2. And the next one is what has to be this? So there's a 1 here, right? Anything raised to 0 is always 1. So 16 raised to 0 is 1, and you're done. So a lot of maths there to understand. So basically, this is where we get confused. So from this step, I use the negative exponent property and make it positive, and then I use the other formula that. So if you have b raised to mn is same as b raised to 1 over n, see, which is nth root of b raised to m. So that's, oh, I can use the other one also. I want to keep the m outside, and b raised to 1 over n, and that is nth root of b and this whole thing. Question number 5 is asking which are the solutions for this equation, and you can see square root of x and there's a minus a. The left side is already plus and this side is a minus, so you can't have like this. That is not correct. So some student you may want to do the squaring both sides. We'll say okay, square both sides and minus 8, and you square like this, and you get x equals 16. Okay, uh, plus 16. And if you want to really check whether this is right or wrong, you just put this inside, and the right side is minus 8. So this becomes plus 8 on the left, and the right, so that's wrong. So this could be an extraneous solution. So this kind of uh, equation, there is no solution. If you want to see the graphical, if you want to know the graph of this, let me show the visual. Suppose you have the x-axis and the y-axis. The square root graph is this. This is how the square root of graph, the left side. And there are two equations you can think. One is square root of x, and the other one is minus 8. So the second one is a line which is 1, 2, 3, 4, 5, 6, 7, 8, minus 8. So this is the line, and you can see this is y is minus 8, and this is y equals square root of x. So the green graph and the red graph, they never cross each other. So there's no solution here, no solution. So if you say there is any solution, it is called extraneous solution, which I already showed. So this question is asking us find the solution to each equation. So all you do is first subtract 6 both sides. So when you subtract 6, you get x squared equals 49, and then x equals plus or minus square root of 49, because when you have x squared is b, remember x is uh, plus and minus square root of b, because square root of b and square root of b is b, and minus square root of b and minus square root of b is also b. So both of them, see, this is this square and this way. So that's why we have two answers. One is plus square root of 49 is 7, because 7 times 7 is, and you get like that. So these are the two answers. For the second equation, you'll have to subtract 16 both sides, and you can see that x squared is minus 16. And because there's a square on the left, so when you multiply two numbers, and it will be always gives you positive, but now it says it is minus, so you cannot have minus, so we say there is no solution. But later classes we will see we can use a complex solution. It means if this is the case, we are going to write it as plus minus square root of minus 16, which is same as square root of 16 times square root of minus 1, and square root of 16 is 4, but this square root of minus 1 is defined as imaginary unit I, and we write I, so the two answers become minus 4i and plus 4i. So these are called complex solution. Complex solution. So they are not real solution. In other words, if you see, this basically means the x square. The x square is the graph. This is the graph of y equals x square, and minus 16 means it's a line through like this, and you can see the two red graph, they never cross each other, so there is no real solution. So no real. Okay, and the third one, so this problem you have to first add 3.25, 3.25, and you will get x squared becomes equals to 25. And then you write x equals plus and minus square root of 25, which is 5 because square root of 25 is 5. And this there are two answers. One is with minus 5 and the other one is x equals plus 5. And you're done. So this is lesson number 9. Lesson number 9, the learning target is I can solve equation with radicals in them. So if you see this, the first one, you can see radical in them, the equation contains the radical. This type of thing, even I did some problems on the in the class. So first step, you subtract this and drop down, you get x plus 5 equals 3, and then you square both sides. So that means you get, so square root of b and square is b. So I mean, you can just cross there as the opposite inverse of each other. So the left side will be x plus this, the radicand is x plus 5. So this x plus 5 becomes equal to 9. And if you subtract 5, we get x equals 4. And you can plug it in and check also if you want to check that whether the answer is correct. And you can put, so we want to know whether the equation balances. So this 4, if you replace here, so the whole thing become 9. And square root of 9 is 3. And 3 plus 7 is, and 10 equals 10. And that is true. So this answer is correct. That's the second one. Uh, So in this case, first you subtract 3, and if you subtract 3, you get square root of equals minus 5. So this combines to minus 5. This now the left side is the square root of, it means it is plus on the left, and this side minus. You cannot have minus and plus, so this is not true. So if this is not true, this equation does not have solution. And I'll go one. Okay, to understand this graph, if you want to see the visuals of this graph, it is the square root graph. This is the original graph. Square root. It moves 2 units to the right. So 1, 2. This is the graph of y is square root of x minus 2. And the second part is y is minus 5. So that equation would be 1, 2, 3, 4, 5. And you can see those the graph, the square root graph and the line, they never cross each other. So there's no real solution. So this equation does not have solution. That's all it is you're supposed to. Question number 2 is says for each of this equation, decide how many solution it has and explain how do you know. Like the first one, remember if f x squared is b, then x is plus and minus. So there are always two solutions if there is a x square. So in this example, because the exponent is 2, we can write that this will stay the same. So x minus 4 will be equal to plus minus square root of 25. And square root of 25 is 5. So you have two equations. One is x minus 4 is plus 25. And the other one is x minus 4 is minus 25. So, sorry, 5 and plus 5 and minus 5. Now add for both sides and you get the two solutions, which is x equals 9 because 5 plus 4 is 9. This crosses out and get x equals minus 5 and plus 4 will be minus. These are the two. So two solutions. If you see the second case, the left side is plus and the right side is plus. So all you do is, and because there's only a plus sign, there will be only one solution. So squaring both sides, So squaring, so square both sides. So the left side will be just x minus 4, and the right side will be 25, and you get x equals 29, and you're done. Problem C is we can add first 7 both sides. So when you do this, this crosses out and you get x cubed is minus 13. And this can be written as cube root of minus 13. And this will have only one solution. So this is exact value of square root of minus 13. The graph of square root square root graph is always something like this. So this is as good as writing also minus cube root of 13, which is the same thing. But here you want to know what is at minus 13 would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, minus 13. See? So it's like you want to know what is this point there. So when it is minus 13, the value here is cube root of minus 13. On the calculator we can figure out. The last question you have to divide 6 here. So dividing by 6, you get cube root of x is, sorry, 0, because 0 times 6 is 0. And the only solution, or you can cubing both sides by you can use your common sense, and only way this could be 0 is the cube root of 0 is 0, because 0 times 0 is the only number which gives you 0 cube is 0. So cube root of 0 is 0. So here we can say x is 0 cube, and that is x equals 0. So again I repeat, you have cube root of x is 0. So you are cubing both sides. So that means you do this one, see? So this and this crosses out, and you get x equals 0 cube, and that is only one solution. So Jada sees that by just looking at this equation, Jada is saying, no, I don't want to solve this. She's saying, I don't want to do algebra. She's saying, I can just do it without algebra. So what did she think that? That means on the left side she saw plus, on the right side she had. How can you have plus on the left and the minus on the right? So that itself is wrong to say. So by just knowing this, you know this there is no solution for this. And if you want to square and solve this, you are going to get some kind of seems to be a solution. Like if you square this, like say, so it's like 6 minus x is going to be 256, and then uh, you subtract 6 both sides, so you get minus x equals 250, and then divide by minus 1, and you get x equals minus 250. Now this type of solutions are called extraneous solution. They appear to be solution, but they are not, because if we plug this in here, you won't get, it doesn't balance there, so it doesn't make sense there. Okay, if you plug this in here, this becomes 6 minus of minus 250, and the right side is minus 16. So this two negative makes it positive, and 6 plus 250 is 256. And the left side is square root of 256 is 16. So you are saying 16 is minus 16, and that is false. Question number 4 is so one student by name Tyler, he took to solve. So he solved this equation. What he does is, you see, starts with this. And how did we get this? That means he squared both sides here. And when he squared both sides, uh, uh, so this negative 5, when you square, got 25, then subtract 3 both sides, and you got x equals 20. The question is this answer correct? So all you have to do is, let's plug this in the original equation here and see what happens. So I'll put here 22 plus 3 equals negative 5, and you end up getting 22 plus 3 is 25. and this is square root of 25 is 5, and you're saying 5 is minus 5. So how can this be correct? So this is false. So this answer that you got, this is called extraneous solution. It is not the solution of the original equation. So could we do this without even showing this work, Tyler? Yes, he could have said. So the question is, what mistake did he here? So because the left was square root of x plus 3 and the right was minus 5, so the left side is plus and the right side is minus. This itself, makes the equation do not have a solution. So this equation does not have real solution. So, and you're done. That's all you're supposed to write there. There was another question B which says, what mistake did Tyler do? That means Tyler in the beginning itself made a mistake of squaring. He could have easily said that this is plus and that is minus. So by just knowing this fact, that you could say this does not have a solution. Okay, so with this I complete question number 4. I think this one I gave a question. Lesson number 9 have only 4 questions. Actually, there was question number 5 and 6, which we already done in earlier lessons. So let me go directly to lesson number 10. So lesson number 10 is a new kind of a number. So the goal here is I can represent square root minus 1 and multiples of it. So that's like a number, or imaginary unit it is called. It is a new number invented. So let's invent a new number. So let's go directly and see how this works. So the main goal is a number on the imaginary number line. It can be written as bi. So imaginary number is a square root of -1, where b is a real number, so any multiples, and I square is -1. As I progress with the practice problem, you'll get an idea exactly of what's going on. So let me go straight away to the first problem. So this is lesson number 10. And the first question, which are the true statements? Now, first, is this statement true? Square root of -1 is an imaginary number. Yes, this is true because the mathematician invented this number, because on the number line, this is the real number line with 0, 1, 2, 3, 4, and -1, -2, minus. In between, you have all these numbers, irrational, irrational, everything. So these are real numbers. It means if you have any number and if you square, it's always going to be positive. That's all it means. But if I say x square and if I write, let's say, -3, we know this is never possible. So this is never possible. It's like I can't have x square equals -1. So the mathematician invented a new number. They said, okay, let's call it as square root of -1. Which is the letter used is I, because this is the number. You say, okay, if you plug this in here, so this part, which is same as square root of -1 and square root of -1, you end up getting -1, which is right here. So this is a solution to this equation, and that's why we call it a solution, or complex solution, imaginary solution, not on the number line. So not from here, but something different. So that's why that's why we use this square root of -1 special letter, which is square -1. This is imaginary unit, which is also called imaginary number. And you can't put it on the number line. So what they said is, okay, let's put it somewhere at a distance of 1 and somewhere here, let's see. So this is put at the point here, and so we call this as square root of -1. Or if you go another one, that is 2 square root of -1. If we go another one, that will be 3 square root of -1. If I go downward, we'll write minus square root -5, right? So this is how the mathematician invented the imaginary line, and now I can draw imaginary line like this. See? So it looks like the y-axis, but the mathematician Argand, he represented this and say, okay, all the complex. So very soon we'll have a lesson on complex number. So the complex numbers is using the two parts. One is the real part here, and one is called the imaginary part here, where you put 3 and maybe 4i. So with this I is what is the imaginary part, and this is the real part, which is the definition of complex number. We will see this later, but right now, just understanding that what is the meaning of this thing? This thing is imaginary unit because that's the one which is the solution to this x squared equals minus 1. Okay, so the first thing is this is true, the first part. Now, there are no real numbers that satisfy the equation x equals minus 1. And this also is true. So we don't have, and this is what I was trying to show here. What it is basically means is, let me take all this off. Okay. So what this means, if you square this, so if you square this, so it means x squared is minus 1, see? And we say there is no x, we don't have no real, there is no real solution means there is no real number on the line. You don't have no numbers on the line that will make it equal to minus 1 because we know that square is always positive, it will never be negative. So this is also true statement. And the next one is this is the imaginary number. No one does math with it. False, because we do math. That's why we have defined. So because we do maths with this, we do some problems on this. So we are going to do later on problem on. Let's see, if I have x squared plus 4 equals 0, solve. So we do maths like this. So you subtract 4 both sides and you get x squared is negative 4, and we can write x is equal to plus minus square root of negative 4. So we are going to do more of this in the next lesson. So this is false. And the third is fourth equation. This has no real solution. X squared equals minus 1 has, it says has real solution. False. It does not have real solution. That is wrong to say it has a real solution. And the last one is, first of all, square root of minus 1 is because minus 1 is, how this is minus 1 is plus 1 is minus 1. Doesn't make sense. That is itself is false. And this also is false. This is square root of minus 1 is I, and you are saying I is minus 1. So this is false. So that is not correct. So question number 2, you're supposed to represent each of these on the number line. So if this is the number line, if you see the first one, square root of 4, it is positive square root of 4. So it is plus 2. So plus 2 is right here. So this is the number square root of 4. The second one is minus, that is minus square root of 4, which is minus 2. So the minus 2 is minus square root of 4. This is square root of minus 4 is, remember there's a minus inside, so this is square root of minus 4 times, 4 times, and then we write this as square root of 4 times square root of minus 1, and square root of 4 is 2, and this becomes I, because I is represents square root of minus 1. And because it is 2, so all we do is you plot the point, 1 point, spacing 1 and then 2. So this becomes, so this is the point which is square root of negative 4. The next one is square root of 8 is almost close to square root of 9. We know square root of 9 is 3. So 8 is smaller than 9. So that means if this is 3, so So this will be little, if this is 3, so this will be somewhere here. So I'll put it somewhere here. So this is square root of 8. And the square root of minus 8 will be minus here, that will be closer to minus 3 here. So this is minus 3. So somewhere here will be minus square root of 8. And finally, what is this? This is square root of 8i because there's a minus. So that means, as I said, square root of 8 is almost like 3. So if I want to use the number on the imaginary line, so this will be little 1, 2, and some. If this is square root of 9 minus 9, which is which is 3i. So that will be this point somewhere here will be square root of 8, square root of minus 8i. I hope this makes sense. Oh, a lot of work, right? So the question is, you guys get confused with how did I get the square root of 8? Because square root of 8 is almost 3, so I just took it to the left of 3 here. And here I took it to the right of negative 3, which is here. So be careful there. So the main goal is, can we understand this and this one? And you can see, so this is same as minus the 2i. So this is spaced out 2 here. So this is that 2i. And the second one is whether we know how to graph this. So as we solve more and more like problem like this, you'll understand better. Okay, question number 3 is straight away explain why this equation has no real solution. When you say no real solution means no value on the number line will give you the will satisfy this equation when you plug in. And you know there's a square here, so anything square is always positive. So you can't have a minus like this. So the moment you see this minus 1, square is never negative. So this itself it is no solution. So there is no, but we can find a imaginary solution, a complex solution. So what is that? We'll do right there also. So uh, not from the number line, but from the imaginary line. What it means is you take the square root both sides, take square root. So it is x minus 4 is plus minus because there's a 2 here, square root of minus 9. And remember, if you have anything inside, it's same as writing the square root of 9 times square root of minus 1, but you know this is 3 and the other one is written as I. So that's 3i. So this will be plus minus 3i. And then you add 4 both sides. And this becomes x equals 4 plus minus 3i. So x has got two answers. One is 4 plus 3i, and the second one is 4 minus 3i. So these are called complex solutions. Complex solutions. So they are not from the real number line. So they are from the imaginary line. So when I say imaginary line means if this is the real number, so these are the imaginary dots, see this part? So this will be like a I, this is 2i, this is 3i, and down will be minus I, and so on. So I hope I made sense. Okay, question number 4. Which value is the closest to 10 raised to minus? Now, what is 10 raised to minus half? Remember, if it is a raised to negative, we can write this into positive exponent by dropping down a raised to p is plus p. So this is 1 over 10 raised to half. So that is equal to square root of, so this is square root of 10. And this number is, we know if it was square root of 9, square root of 9 would be 3. Because 9 and 10 is almost close to 9, I can say, okay, this is almost close to square root of 9, and that is 1/3. So this value is, this thing, this thing is close to 1/3. Question 5 is, what is the solution for this? So the first is subtract 5. We did this problem so many times, this kind of problem, but let's really get this. Let's become 5. And then you square both sides. So you could solve this because there is a plus here. That's why. So squaring both sides. So the left side will be just 6 minus x. 5 times 5 is 25. Subtract 6. So you get minus x equals minus 19, sorry, plus 19. And divide by minus 1, get x equals minus 90. And that you can always check also by plug. If you want to check, so you can put 6 minus of minus 19, and you can see you get uh, two negatives mixes positive, square root of 25, and you get the answer. So you are right. So the answer is minus 19 here. Okay, so the last question is this one, 6. So let me see if I can do the snipping here. Oh, yeah, I can do. So the question is, select all the solutions for which minus 64 is a solution. So we want to know if I put x equals minus 64 in each case, do the equations are true? If I take the first one and I put square root of minus 64, and you can see you can't have a square root of negatives, right? This is wrong because this is plus here. Uh, this itself is you cannot have a square root of negative 64. So there is no solution. This there is a complex solution. Actually, on the left side, the value becomes square root of 64 times the square root of minus 1, which is 8 and I. The right side becomes 8. The left side is an imaginary number. So this is false. So this is not a solution. So I'll put the second one, square root of x is minus 8. So if I put here square root of minus 64, again, it's the same idea where this is not correct. You cannot have a negative because this is going to be 8i, and you are saying 8i is minus 8i. This is again false. Let's put it here. Cube root of negative 64 is 4, and this is correct because minus 4 multiply minus 4, this is minus 64. So this is correct. Oh, sorry. So this not a plus 4. This is correct. I'm talking about this is this one. I'm so sorry. So if we plug in for minus, it works because minus 4 minus 4 minus 4 is minus 64. So cube root of this is true. That means D is correct. But so let me clarify this. This one is different. This is cube root x is 4, and in the C, if you put minus 64, it is cube root of minus 64. The right side is plus 4, but the left cube root is minus 4. So you are saying minus 4 equals to plus 4, and this is false. So this is not a solution. This is not a solution. This is not. But this is a solution. What about the bottom part? So let me take this off. Let's put in this part. So this is minus square root of minus 64. And again, you can clearly see you're seeing square root of negative. This itself is wrong. So that's no solution also here. What about the last one? So square root of minus, and there is a minus 64 here. So we need to put minus 64, and you're seeing this equals the 8 on the right. And you can see this two negatives makes it positive. So you get square root of 64 is 8, and square root of 64 is 8. 8 is 8. This is true. And that's why this is correct. So I hope this finishes the lesson number 7, 8, sorry, 8, 9, and 10. I want you to watch these videos again just so that you can understand all the intricacies or detail understanding of uh, cube root, then square root, fourth root, and then all those formula that we did, all the formula that we did. Okay, so let me, if I so just wanted to conclude with this. What did we learn here is this lesson is about imaginary numbers. This is something, a new number that you learn. I just want to make sure I get that part. So square root of minus 1 is straight away is called I. And if you square, it means if I write square both sides, I square is minus 1. This is one and the same thing. And if I have anything minus 9, you can always write it as 3i. If it is square root of minus 4, you can write it as 4i, sorry, 2i. If it is square root of minus 25, it is 5i. But if it's not a perfect, let's say minus 7, then you'll have to put square root of 7 and then the I. So this is how it works. Okay, see you guys and make sure write all the solutions